Welcome students. In this video, we will be discussing about the recursive implementation of displaying linked list. So previously we completed with the iterative concept of displaying linked list and also the implementation, iterative implementation. And now we are into the recursive implementation of displaying a linked list. Already the concept is over. Now we will enter into the implementation. Right, so already we have taken a node structure, we have written a function for creating a linked list, and in the main function we have already called that create function also. So now what we are going to do is, okay, now what we are going to do is that let us write, okay, already you have written one display function, and this function is actually display the linked list, but this is actually the iterative approach. So it is going to be like iterative approach of displaying a linked list. But now we are going to write a function. So to display the linked list. Okay. But now what we are going to do is actually going to be recursive procedure of doing it. Right, coming to the recursive procedure, like for example, the same thing that we have what we have done in the concept lecture. I think hope you remember about what we done in the in the lecture. So here the same function but with a different name, r display, same parameter, while condition converted to if condition, and when there is a change in temp pointer we have made a recursive call. Right, we'll follow the same here. So the name of the function that we are going to take it is r display, okay, 1 minute, or display, and followed by a parenthesis where we will be passing the address of the very first node. So struct node star temp. Okay, after taking that, we need to be checking the base condition. We need to be checking whether that temp is actually not equal to null. If it is not equal to null, then what we can do is we can proceed with our recursion. But before recursively calling the same function, we need to first of all print the data. So percentage d space comma temp of data. So we are going to print the data. After printing the data of the node which that pointer temp is referring to, after printing it, we should ask the temp to move to next node. Start referring to next node. So instead of writing temp equal to temp of next, we're going to call the same function r display, and in the argument instead of passing temp we are going to pass temp of next, which is literally equal to temp of next, because here the receiving place temp, here passing place temp of next. So what will happen? Temp equal to temp of next. The same temp equal to temp of next we are doing it in the recursive way. Right, so let me save this. And here instead of calling your display, now the iterative display, let me call r display and let me pass the address of the first node and check whether all the things are working properly like iterative approach. So let me call gcc -o hello, and the name is going to be, name of the function is actually, name of the file is display linked list iterative.c. Yeah, everything is okay. Now we can go for execution. Like 23, 34, 45, 56, 67, 78, 89, keep on going, but now let me enter -1. So you are giving input like 23, 34, 45, 56, 67, 78, 89, and when you provide -1, the process stop. So whatever values that so far you have got, those values, that what you're doing, you're displaying it again. So the recursive approach of displaying the linked list is working fine. But let me show you what is happening exactly inside the compiler. Not already I have shown you, like manually I have shown you by drawing the stack structure. But here let me show you the compiler itself, what the compiler is doing. Right, so we'll see that. Okay, for example, we can just place, okay, so what we should be doing is that scanf we are having, right? Okay, 1 minute, please. 1 minute. Let me try to execute from here actually. We'll try. But 1 minute, just give me 1 minute. Guys, so students, in order to show you the debugging process, we cannot use scanf in the debugging process. So I have just taken out scanf, and the very first element I have assigned 34 in the compile time, second element 23, and the subsequent element we have just been decrementing from 23. I will be decrementing by 4 again. So 23 minus 4 will be 19. The next value will be 19. Again minus 4, it will be 15. Again minus 4, it will be 11. Again minus 4, it will be 7. Again minus 4, it will be 3. Again minus 4, it will be minus 1. So that point of time, this process will stop. So the elements are going to be 34, 23, 17, sorry, it's like 19, like 15, 11, 7, 3, that's it. So these are the elements that we are inserting. Okay, right? Instead we are just taken scanf just to show you the debugging process, right? Fine. So we are going to start the process from main function. I think main is also a function. So when the main function is called, what will happen? Activation area have to be recorded for, have to be created for that main function. Am I right? So we'll just check whether is everything is working or not. Right, fine. So now you can able to see here in the call stack. Okay, let me just take it off. Here you're able to see in the call stack, there is this is what the activation area. So the activation area called as main is actually created. Okay, the inside main, there is no variables that we are taking inside main function. So the variable section is completely empty. There is no variables inside this main activation area. So let us go to, let us enter into this create function. So let us step into, and once you step into create function, you can able to see initially there was a activation record for main. Now we have created an activation record for create, because this is also another function. So whenever a function call is made, one activation record is created here in the call stack. So now coming in, what is the first line? First line, 31th line is, creating a block for pointer first and last. That by default it has happened already. So first is having, first is a pointer and last is also a pointer. And also so far x is also one other variable that we have declared inside. So all the memory blocks are allocated before we execute it. All the memory blocks are already created. Once you call the function, all the variables inside that function is already created with some temporary value. Now executing 32nd line, what you are doing, you are going to create a memory in the heap here you will not be able to see. So you are going to create a memory in the, that is, you're going to create a node in the heap memory, and the address of that node you are going to place it in the pointer first. Let us check. Okay, so this is the address 0x9b17f0, a hexadecimal representation. So this hexadecimal is the address of the block that you created in the heap memory, the node that you created in the heap memory. Okay, now that address is now stored in the variable first. Now what is the next thing? The next thing is x is equal to 34. So initializing x is equal to 34, you can see here, executing x has become 34 now. So now coming here to first, what a first is having? First is a pointer that is actually having, it is referring to a node, right? That node is actually having a data part, and also it is having a pointer to next. Right? So now what we have to do is, first of data, we will be inserting the first element. So what is the first element? 34. So 34 will be inserted in the data member. You can able to see here in the first node, data member 34. Now that node becomes the last node also. So coming here, what we are doing, we are giving the address 0x9b17f0 to the variable called as, to the pointer called as last. You can able to see now, if I execute 36th line, the same address will be coming here for the last pointer also. Can you able to see here? Same address 0x9b17f0. Now both first pointer and last pointer are referring to the same node. I can expand and I can show you. See here, same thing. So now the pointer called as first and the pointer called as last, both are actually referring to the same node. Okay, fine. Now what's 37th line? Last of next is equal to null, which means that the same node, the first node next will be assigned to null. You can able to see both cases null. Null means it is actually 0. Null means 0. So 0 is assigned in both next. So both are actually null. Okay, 0x0 means it's null. So 0x0 means it is a hexadecimal representation of 0. So null is actually equal to 0. So 0 you are storing in next. Right, fine. Now what's the next one? Next one is you are changing your input x equal to 23. So execute this. So x has become 23. Now you are starting with a loop where x not equal to -1. Yes, the present x is not equal to -1. So you can enter safely. After entering here, what is the first line? You are going to create. See here, once you enter into the while loop, already there is a pointer called as temp. Okay. But now what you are going to do is we will be creating a node in the heap and that address you will be assigning to temp. So you are ready to create. See now, see you are ready to create a new node. Okay. So let us just create a new node. So after creating a new node, the address of that new node is actually now here 0x9b1830. And you can see inside the data part is having some random garbage value. Next is also having some random, garbage, address. So now what is the 43rd line? Temp of data. That's a newly created node. Data member, we have to be inserting x value. What is x value now? X value is actually 23. So 23 have to be initialized to the data member of the new temp node created. So you can able to see here data part is changed to 23. Now first node you have both your first pointer and last pointer are referring to the same node. So first hereafter we will not be affecting this. So last pointer is having like 34 is the data and address is 0x9b17f0 and the pointer next is actually having null. And now what we will have to do is that last of next, you have to take the address of the new node created and you have to store it in the last node next member. Right? So last is actually now referring to the first node, and in last of next what we are going to store, we are going to store the address of the new node temp created. So what is the address there in temp node? 0x9b1830. So this address will be now stored in last of next, which means this position. So let us execute and just check. So can you able to see the same address? The address of the temp, that is 0x9b1830. And this address is actually stored here in last of next. Last of next means last and first are more same node only. So in first of next also you are having the same address. So now how many node you have total? We have a total of 2 nodes now. First node is represented by, first node is actually pointed by 2 pointers first and last. Second node is referred by temp. The address of the second node that we have stored in the first node already. First node of next we have already stored. And now the newly created node will become the last node. So now what the address of the new node, we have to assign it to last pointer. So now our last pointer will automatically start referring to the lastly created node. Now if it is the last node, definitely the next position have to be null. If something is the last node, definitely pointer to next node should have null. So let us initialize last of next equal to null. You can able to see that it is equal to 0. Okay, fine. So now only 2 nodes created. Address of the first node is there in first pointer and address of the second node is available in the first node second next pointer. Okay, done. Now what you can do, you are going to decrement your x value by 4. So x was 23 and now if you decrement it by 4, it will change it to 19. Now again what you have to check, x not equal. So loop is completed and again the loop is coming again to the condition part. Now x is not equal to -1. If yes, x is not equal to minus 1 because it is having 19. So if it is 19, so you have to create a node for it. So you are going to create a new node. So this malloc will be creating a new node, and that address of the new node will now be assigned to the variable called as temp, right? So you can execute and we can check that there will be new address. Yeah, there is a change of new address. So this is a new node created, whereas data part is also having some random value, and the next pointer is also having some random value. Okay. So now after creating a new node, whatever is the new x value 19 have to be inserted in this temp node. So temp of data equal to x. So this is the third node. Third node data is now 19, and now the address of the temp node have to be assigned to the previous node, that is to the second node. So the address of the second node is available with the last pointer. So that last pointer, pointer to next node we have, right? So that pointer to next node, what we are having null. But instead of that null, we have to take the address of the newly created node and you have to place it here. So this 44th line will take care of it. So address of the newly created node is placed in the last node. Okay. Now the newly created node have to become the last node. So now the address 0x 9b 1870 will be assigned to the pointer last. See here. Now the last pointer started referring to the third node. So if it is the last node, then the last node next pointer, what it should be? It should be equal to null. So the last pointer to next node, we are going to initialize it to null. Yes. Now again we are going to decrement the x value by 4. So our new x value will be equal to 15. So again 15 is not equal to minus 1. We will enter inside. We will create a new node, and the address of that node will be assigned to temp pointer. And now in that new pointer, that is the temp pointer, we will be assigning the date, that is we will be assigning the x value 15 to that data. So now the data part becomes 15, and then the last node you have to place the address of the present node have to be placed in the last node next position. Okay. Then after that, the newly created node has to become the last node. So last is equal to temp. So last started referring to the newly created node. If it is the last node, then the next pointer should be equal to null. So that is equal to null. Okay. So now again what you have to do, x minus equal to 4. But before that, let me show you something here. First pointer. Okay. Let me expand first pointer. First node is having the data 34. Then in the next pointer, you are having the address of the next node. Let us expand that and check. Expanding that, you see the next node is actually having 23 data, and that node is actually having the address of the next subsequent node. Expand that, and the next node is actually having data 19, and then the next pointer is having the address of the next subsequent node. Expand that. What you are having? You are having the address of the fourth node 15. You are having the data 15, and then the next pointer is having null character. Let me expanding. We have nothing here. We have nothing, right? Okay. So hope you understand how this linked list is actually stored in the background, actually in the inside the compiler. Okay. So again what will happen? Again what you will do is x minus equal to 4. X minus equal to 4. So when x minus equal to 4 is carried out, your x value will be changed to 11. So let me just shrink it. Okay. Fine. Now you have the address of the first node and you have the address of the last node. Now what you have to do is that the present x value is not equal to minus 1. So you will enter inside, and you are going to create a new node with the help of malloc. And after creating new node, the address of the new node will come here to temp pointer. And now this is the new node created. So in the new node data, what you have to do, we have to insert the new element 11. And then this is a new node, and already we have the address of the last node. I think the new node address we have to place it in the last node. So last of next we have to be storing the address temp. So that is what is going to be carried out here. So the address of temp will be now stored here in next. So 0x9b18f0 is stored here in the last node. Now the newly created node itself have to be the last node, because one more new node is created, so that node will become the last node. So last equal to temp. So now last pointer will start referring to the new node. Now, if this is the last node, then the next pointer should definitely be equal to null. So we are initializing it to null. Then what you are doing? Again, we are decrementing the x value. We are again decrementing the x value by 4. Okay, so let us decrement it by 4. Okay, our new value is x is equal to 7. So 7 is not equal to -1. Enter inside, create a new node, and insert a data in the new node. Then take the address of the new node, place it in the last node. Okay, so last node is having the address of the new node created, and then our newly created node becomes the last node. So temp is assigned to last. So our last will also start referring to the last node. Then if it is the last node, then the next pointer should be equal to null, and then again your x value have to be decremented by 4. So our x value becomes 3. 7 minus 4, 3. 3 is also not equal to -1. So create one more node, and in that node assign the data, that is 3. Assign x value to that data. So temp of data will be equal to 3, and take the address of this temp and store it in the last node. So in the last node next you will be having the address of the newly created node, and now the last node, even that newly created node will become the last node. So last node is now going to refer the newly created node, and if this is the last node, then the next pointer have to be equal to null. Right, now again we will be decrementing our x value by 4. So 3 minus 4 will be equal to -1. Now x not equal to -1 is a false condition. So the condition is false, so you have to come out of while condition. So we have come out of the while loop, and now we are in the 15th line where we are going to call the display function. Remember very well that, let me show you the first pointer. First pointer, that is the first node, is having data 34. And in the next pointer we are storing the address of the next node. So let me expand it. So first node is 34, second node is having 23, and the third node is having 19, and the fourth node is having data 15, and the next node is having data 11, next node is having data 7, next node is having data 3, and the next node you have actually null character where you can actually stop the process. So this is how you are linking each and every node, right? So let me shrink it out. So now we are going to call one more function called as rDisplay. So far there are two activation record. Now calling one more function, one more activation record will be created. You can see here main activation area, on top of it activation area of create, on top of it activation area of rDisplay. Now the first condition is temp not equal to null. I think now the temp is actually storing the address of the very first node. Okay, you can see, able to see the same address. I can again move back to create activation area. Let me click on create activation area. What is the address of the first node? 0x9b17f0. Let me go back to rDisplay. The same address is actually passed to temp pointer. Now temp is actually pointing to the first node, from where you can actually reach out to all the other nodes, because the addresses are stored in every node, right? Fine. So is temp is equal to null? No, it is not equal to null. So the condition is true. So you enter inside, and what is the first line? Printing temp of data. So what your temp of data is? Temp of data, you can clearly see here, data is 34. So executing this statement, 34 have to be printed. Okay, now we will come, but 34 is now printed. Okay, that I will show you how it is printing. 34 is printed. After printing 34, the next one is 24th line, calling the same function. So when you call the same function, what you have to happen? One more activation record have to be created, but with what is as a parameter? Temp of next. What is temp of next? temp of next is having 0x9b1830. So now the new temp will be having 0x9b1830. So let us step into that new function call. When I step in, you can able to see that one more activation record for our display is created, and the value of temp is the address of the second node, which is 0x9b1930. I can probably show you here in our display, that is the first activation area of our display. It is having the address of the first node. Then coming to the next, now the topmost activation record, it is having the address of the second node. Now, again we will check. Is temp is not equal to null? Yes, temp is not equal to null. So I will enter inside. I will print temp of data. So what is the temp of data now? The temp of data now is actually data is 23. So I will print the data 23, and I will again move to, again I will execute the recursive call. In the recursive call, what is the parameter? Temp of next. What is the temp of next value? It is the address of the third node, which is 0x9b1870. Right? So now you are going to call the same function again. So one more activation area will be created with the argument 0x9b1970, address of the third node. We'll check. So you can able to see here there is totally now 3 activation records. So a new activation record is created for our display, but the argument value is 0x9b1970, which is the address of third node. Now, I think temp is not equal to null. So we will be, printing temp of data. Temp of data is actually 19. So 34 printed, then 23 is printed. Now 19 is printed. Okay, we will enter into this condition. Then we will be printing that, 19. And then the next one is we have to call the same function again, but with temp of next. So what is the temp of next value? Temp of next is 0x9b18b0, which is the address of fourth node. Right? So now one more activation area will be created with the argument having address of the fourth node, and the data is 15. So now the temp is not equal to null. So I enter inside, I print the present data 15, and then again I go for the next recursive call. So what is the next pointer is having? It is having the address of the fifth node, which is 0x9b18f0. So that will be given to temp. Now a new activation area will be created with the address of the fifth node, and the data is 11. Again, temp is not equal to null. Enter inside, print the data 11. Then again go for recursive call with temp of next as the argument. So 0x9b1930 will become the new argument of next. So one more activation area will be created with the argument of the, the sixth node actually having data 7. 0x9b1930. So temp is actually not equal to null. So we enter into if condition, we print the data 7, then again we have to go for the next recursive call. The next recursive call, what you will happen? Present temp of next, that is 0x9b1970 will become the new argument. So one more activation record will be created, and for that activation record, what has to happen? Data is 3 and the address is 0x9b1970. Temp is still not equal to null, so I will just enter inside, print the data 3, and then I will again have to go for display. But what is there in temp of next? You are having null. So one more activation record will be created, and where now temp has become null. So this condition becomes false. So you come out of condition. So when the close curly braces is created, now let us check how many activation area for our display. 1, 2, 3, 4, 5, 6, 7, 8 activation area has been created so far for our display. Now the close curly braces of the topmost activation record is actually executed. So once you execute this statement, actually one activation record will be created. I mean, it has to be eliminated. I think all the activation areas are one after the other have been deleted, because for all the activation area, all the lines of code have been already executed. Now you come to the last line of create function. So what have to happen if this close calibration is executed, then the activation record for the create function will also be deleted. Then you enter into main activation area. Then what will happen when you execute this closed curly braces, then the activation record for this main function also will be deleted and the execution of the entire program is completed. That's it. Right? So what I can just show you is that I think already, I think the input is not actually, I think, printed. So I think probably we can just go for execution. So execution, already we have seen that the output is printed perfect, right? So we will just simply go with again executing the same line of code. So okay, already execution, what we have done, we have inserted element 23, 34, 45, and like 60, 56, 67, 78, 89, and then minus 1. So all these things are inserted properly. So let me just revert back the same program. Instead of having x is equal to 34, let me introduce scanf. Okay, so x equal to 23, I'm going to take it off. Then x is minus equal to 4, I'm taking it off. Right? Fine. So this is actually the recursive approach. The background execution also we have seen. So now it is time for us to get into the time complexity and space complexity analysis of both the iterative as well as both the recursive approach. Right? So hope to meet you in the next video. Thank you, students.